Hey guys, welcome to my first YouTube video. So in front of me you can see the GeForce GTX 1660 Super from Gigabyte, and the card is supposedly faulty. So let's take a look together and see if we can diagnose it and maybe hopefully fix it as well. So let me open the box. The card is here inside. Let me just move the box because we don't need it for the moment, and take out the card from the packaging. Okay, we don't need that as well. Okay, so that's our card. 2 fans. Looks okay, I would say. Nothing extraordinary, I would say. Nothing draws my attention for the moment. And so basically, upon visual inspection, if we don't see anything obvious, then I would just disassemble the card. Of course, we can make some measurements before, so like check the PCI Express slot. Here, if you can see, there are some coils. I mean, maybe I say it better than you, but some coils like here can be accessed, and here can be accessed even with the heatsink on. So we could probably check most of the resistances on the card. However, I think it's gonna be just more comfortable if we disassemble the card. So let me unscrew it real quick. Remove the screws. It should actually be pretty fast. This cooling system is not very complicated and doesn't have many screws, so that's actually, I mean, it's easy to disassemble, but sometimes it's better if the entire PCB board makes the contact with the heatsink and all the components are cool. So probably this is not the high-end cooling system. However, for this kind of card, I think it's enough, and it's okay. Let me unscrew the last screws. Alright. So that should come off. I've seen a few cards like this. Okay. So backplate, we don't need it. I'll put it away as well. Okay, so that's the back of the card, and then let's carefully remove. Oh, there's a fan connector, so because we don't want to rip it off when removing the heatsink and the entire cooling system, and then gently, slowly pry it. Okay, so we have some thermal pad left here on the MOSFETs. That's probably the V-core, so GPU power, and here we have other thermal pads. So for the memories, 6 chips, and for for the coils on the V-core section. So that's it. We don't need it as well for the moment. Later, if we can fix the card, I will give it a clean. The pads are a bit dirty, but only in the places where it was not touching any components, because the components were missing here, and that's how it's designed. So yeah, I think we can even reuse it. They seem to be in a good condition, so probably it's okay to leave the factory thermal pads, but that's for later. Let's get rid of it, and we have our naked card right now. Okay, so what do we do? Well, of course, it's important sometimes to start with the visual inspection. However, I don't see anything obvious here. Like at first glance, I could inspect the board under the microscope. That's also a good way to do it. But based on my experience, I think we can just move to the basic measurements, which will probably tell us more. And yeah, let's see how it goes. So let me turn on the multimeter. I'll try to put it here so that you can see. Can you see it? Yeah, you should be able to see it. That's great. So ground probe. We need to hook it to the ground, so somewhere here, so it's touching and it's stable, just to have a good ground. How to put it? Maybe like this. Oh, that should do. I hope. Okay. Alright, so actually, do we have ground? Yeah, okay, it's fine. So that's short to ground. Okay, that's fine because it's the ground. So what do we measure? First of all, I would measure 12 volts from the PCI Express slot. So the first 3 pins you see here, so there's a lot of pins here, but the first 3 pins are for the 12 volts from the PCI Express slot, and that's one of the main voltages on the card. So I'm in the resistance mode right now. Let's check the resistance here, and we get no reading. Oh well, open line means the pins don't have connection to the board basically. I would expect something in the kilo ohms range, and or maybe even mega ohms, doesn't matter, but I would expect a reading here. If there's no reading, my suspicion is that the fuse is broken, is blown, and I don't see any fuse here, so most likely there will be a fuse on the other side. So let's check it. Oh yeah, we have a fuse here, this white component here with a Q marking on it. So that's probably 10 amp fuse, I believe, from what I remember. So we are in the resistance mode. We can check if there's a continuity. So we expect like the probes shorted have 1.1 ohm basically. So we expect that resistance between two ends of the fuse, and we have mega ohms. So the fuse is blown, so it means there's no power going into the board from the 12 volt pins. Basically it goes here, and then it doesn't go through the fuse to the board. So to actually measure the resistance on the 12 volts, we need to check the resistance after the fuse. So here to the ground, and that's, oh okay, that's 1.2 mega ohms and going down, so it will stabilize, but it's not shorted. So that's surprising, because usually blown fuse, I mean, fuses don't go bad by itself. Usually it's caused by some short or something going bad on the board, and then because of the high current the fuse is blown. So that's surprising, because I expected a short behind the fuse on 12 volts, and it's not. Now we have kilo ohms. It's perfectly fine, so that's surprising. Okay, definitely we need to remove the fuse, either just solder two ends together and remove the fuse completely, can be done for testing, but I think I have 10 amp fuse, so definitely I will remove it in a moment. But first let's carry on with our measurements. So after 12 volts we need to check 3.3, and then on this smaller part of the connector there is this notch here, and from here we take the fourth pin, 1, 2, 3 and 4, and we have around 48 kilo ohms, perfectly fine reading for 3.3 volts. Then we have 12 volts again, but from the PCI Express connector here. So this is where we plug the plug from the power supply. So actually you can measure it here. Inside there are pins, not sure if you can see it, but also those pins are connected here, so the upper ones should be 12 volts because the lower ones are ground, so we don't care about it. Let's check the resistance on 12 volts, and we have in mega ohms, now in kilo ohms, in hundreds of kilo ohms, perfectly fine. So I don't see any short here. Nothing. Okay, so 12 volts is fine. I think this is also 12 volts. It should have similar reading, or we can go into the beep mode to check for continuity. So we should have continuity here, because it's the current sensing resistor, so its resistance is close to 0 ohms. So we should have continuity here, and we should have continuity here. Okay, that's correct. So that's 12 volts as well. Okay, so we have that. Let's get back to the resistance mode. Okay, so let's check the rest of the coils. So that would be 12 volts again from the connector. So we already said it's not shorted, and that only confirms that it's the same reading. Then we have some other coils. Let's leave this section for now. Okay, so let's start with the small ones. Let's start with this one. We have, I don't know what this is, but in 6.2 kilo ohms, that's perfectly fine, perfectly healthy. Alright, so then we check the one here, small one here. Oh, okay, it has quite low resistance because it's only around 10. Actually, if you deduct the leads, then it's like around 9 ohms. But I suspect it's PEX rail, and that's perfectly fine for PEX. So just based on my experience, normally I would be worried with that, but actually with GPUs you have to know that those basic things, that it's perfectly fine. If it's PEX, of course, because if the other one is PEX, then we have a problem. Okay, so the other one is not PEX because it has high resistance in mega ohms, kilo ohms. Right now it's jumping around, but definitely it's not shorted, so that's good news. So